Hey, everybody. Don't kill yourself on the stand, my friend. Welcome. My name is Ian Cooper, and I want to talk to you today about writing modular software. I'm going to do some specific conversation about C#. I think it should be generically useful as a talk, even if you're not a .NET developer. Who is a .NET developer in the room? Just so I get an idea of audience. Who is not a .NET developer, then ask that. All right. Okay. So, but I think you should get value whether you are or not. I'm old. That's all that really says. I've been doing this long enough that when I started, the focus was really on analysis and design and not on writing code, and we seem to have come back full circle. All right. Anyone heard of Brighter? Stick a hand in the air. Oh gosh, we never seem to get anywhere. So we predate really the use of mass transit and N service bus as a messaging framework in the .NET space. They were brokers originally. We are a messaging framework. We've been around for a long time. We are obviously free and open source, and we can't switch on you because we don't take the IP from you when you contribute. You retain the IP, you just license it to us in perpetuity, which means there is no real way for us to go commercial. And we can also act as an alternative to Mediator. So if you've not heard of us, you should have a look. All right. Modular design. Why should you care? Right? I mean, you've come to this talk, but why? Why should you care? There's a useful quote here, which I quite like, by Glenford J, which said, 95% of the words about software architecture are spent extolling the benefits of modularity, and little, if anything, is said about how to achieve it. And I think that is very true, right? Since, you know, the 1970s with Jordan and Constantine and kind of structured design and structured programming, we have been talking about the fact that our software should be modular in order to make it maintainable. And yet we're very bad at talking to people about what that really means. This is the fundamental law of software engineering. I'm sure all of you have it, you know, some of you may have it tattooed somewhere, I suspect, or the rest of you could probably recite it at a moment's notice in a conversation. But, you know, I'm sure. But I will remind you, it is Thursday morning, just in case a few of you have kind of slipped your mind. So it's basically that formula. But what we say is it is always easier and cheaper to create two small pieces rather than one big piece if the two small pieces do the same job as a single piece. This is because combining two problems in one piece forces us to deal with the unneeded interactions between the two pieces. What does that mean? What that means is if I have a problem in software that I want to build something, we will show the example later of my building automation for a role-playing game that I play, the contest generator. That does quite a few things, right? Rolls dice, figures out what the results are like, sets up contests, that kind of thing. All those things are quite individual. And if we separate them out into pieces, it's easier for us to reason about those and to maintain them than if we just put them together as in one. And you can reason about the most basic form of this, which is if you saw, you know, a 5,000 line long procedure or method, you would think, gosh, that's unmaintainable, right? Maybe I could figure out what it's doing in subsections and extract those into methods. And that's effectively a modular breakdown of your code. Right? That's all we really mean. It's going to be easier to break it up into parts that tend to have a single responsibility and where we hide information. So it's based on this concept that is effectively at the heart of most of what we do, right? Generally, if we're going to basically build software, we take a problem, we keep breaking it down into smaller and smaller pieces until we reach a piece we feel comfortable reasoning about. Excuse me. And the same thing is really true of modularity. It's just about breaking our code down into pieces that it's easier to deal with. Now, when Structured analysis and design comes out in the 1970s. The major mechanism for modularity was the procedure. We later moved to things like abstract data types and classes, and in a sense, they are all modules. It doesn't tend to be so much what we mean by module today. We tend to think much more of a kind of unit with some exports, etc., and we'll talk about that a bit later. But really, it's just that fundamental act of divide and conquer. Break things into small pieces that can be solved separately, thereby lowering the cognitive load. I have less to reason about, and reducing coupling. So coupling here, what you need to really understand about coupling is, does changing this have an impact on that? That is coupling. Okay. So the lower the coupling we can get between two things, the easier it is for us to make change, because I can change A and don't have to make changes in B. And that makes it just easier for us to work. Right? Yeah, so manageably small is not everyone's, right? You can find arguments on the internet with, people saying, functions should be about 5 lines or whatever, and some people saying, that's ridiculous. What's wrong with my 30-line function, right? And a little bit that is taste, I think, rather than specific problem. So what are the promises we make about modular software? So the first one comes from David Parnas, and that is information hiding. So an effective module should hide decisions. So if, as part of my software, I need to decide how to do something, then it is best to hide the code that we use to make that decision inside a module, such that effectively if I want to change how that decision is calculated in the future, I could easily do that, either for efficiency or because I've decided the algorithm needs to change for other reasons. So you will see later when we look at the example we're running through, we have some modules that say things like, oh, I'm going to calculate the result of your roll of the dice, right? That effectively is information hiding. Nothing outside there really needs to know anything other than the result. How we calculate it is an implementation detail, which we want to hide from others by information hiding. We want to minimize change complexity. Right? This is the idea of a kind of having one kind of responsibility, such that the change to one module shouldn't tend to ripple out and change lots of other modules. There's this, and it also means, in a sense, cohesion, this idea that my changes should be co-located in one module. There's an anti-pattern which you may see or smell called shotgun surgery. And the problem of shotgun surgery says when I want to change X, I've got to touch 15 or 16 different modules in order to make that change. That's a problem of lack of cohesion, right? My ideas are not contained inside one module where I can go and think about that. If I don't locate it within a module, how we calculate or adjudicate the results of a given contest in the game that we're automating, then and I spread it everywhere, it becomes incredibly difficult for me to want to change that in the future, because I have to hunt down all the places where effectively that is implemented. Whereas if it's in a single module, it's easy. We know, I just go and change that module, right? You can treat the module as a black box. And this is one of the oldest and perhaps most simple advantages of modularity, right? This notion of a black box. And by black box, we mean I don't care about how it works inside. I just care about how it works from outside. So I can press the buttons and I get the effect that I want, right? I don't know how the magic works inside. I pay no attention to the man behind the curtain. But that is very useful to me, because it means that if I am not concerned with the implementation of how to use X, then I don't have to add that to my cognitive load. So I mentioned Brighter earlier, right? So Brighter, effectively, the thing it will do is it tries to mirror, say, the way ASP.NET works. You write a handler, and we can effectively take a message and send it to that handler so that your code can run and just deal with how you process that message. You don't have to be concerned with all of the things like message pumps, serialization, deserialization, the mechanics of the particular transport that you're talking to. All that information is hidden from you. It's just a black box as far as you're concerned, right? So that reduces your complexity. And we nowadays, when we do software development, typically work with frameworks that we just treat as black boxes. We don't tend to dive into all the detail underneath about how it works. So building your own software out of black boxes helps you separate these decisions that you need to understand from ones you just go, okay, I call that thing and I get a decision back. Typically, it will also help us localize defects. If there is a defect affecting a particular thing, I know to go and look at that module that has that responsibility. So even if I don't necessarily have a stack trace or something similar to tell me where to find it, right, I'm going to know, well, that calculation number comes from this module, and therefore I should go and look at that module, because that's the most likely place that I will find the error or defect. Okay. So maybe, we talked a little bit about this notion of information hiding, which is kind of the critical idea in modules. We should define what we actually think modules are. So broadly, a module is really just a responsibility assignment. It says, this thing is responsible for this, right? It's basically a logical definition. So while we may have the ability to represent it in our language in a certain way, really when we talk about modules, we are in that logical space of how we think about programs, how we think about basically taking the requirement space and slicing it up. And typically what we say is our module has some kind of interface, right? Some kind of set of methods, etc., or exports that I can use from the module, and effectively in a hidden implementation. So there's stuff effectively below the surface, which is the detail and the stuff that I talk to. We tend to deal with the name, and we don't tend to deal with the details. Right? We don't want to couple to those details that become important later. So we just want to make sure that the module has some kind of facade or interface at the exterior, and that's what we depend upon, but we don't want to couple to any of the details inside the module. The changes are therefore combined to a module. That makes it much easier for you to work as a team, because you can quite often work on separate modules. You don't have to worry about merge changes, particularly if you're doing something like InnerSource, where you have teams able to make contributions to other teams' repos. It can often help if a team wants to build something new that they build it in a module, because that means you aren't all affected by the work that they are doing within their own module, and they can, we'll come back to this later, typically put feature flags around it. It's also, and again we'll return to this later, much easier if you are doing agentic coding to have the agent confined to working within a given module. Treat as a black box, I mentioned that earlier. So when we talk about test-driven development, one of the interesting things to bear in mind here, if you've seen me talk about TDD before, is that TDD generally talks about behaviors, but we also really care about the public interface and not the implementation details. So when we test a module, what we actually want to test is the public exports from that module and not the details of how the module is implemented. When we talk originally about the idea in classical testing of unit tests are tests of a module. They're generally black box at the perimeter of the module. They are not white box tests that peer into the module. And integration tests just check that your modules fit together. Right. Too often, what we are tending to do today, because we don't use modularity well enough, is expose all of our implementation details to everything in the code base. We don't have the notion of hidden implementation. We don't have the notion of hidden details. We pretty much have tests coupled to everything. And that makes our software incredibly hard to change. Right. So if you find that what you tend to do as a .NET developer is say, it's just all going to live in the one big assembly, you're making your own life hard, because you haven't decided to say, hey, I just want to have these module blocks, and I just want to test the behavior of the module, not the implementation details of the module. Refactoring is the art of changing the implementation details of a module without changing its public interface. That's its technical definition. If what you're doing, and you say I'm refactoring, and you're changing lots of public types, that's not what refactoring is about. Refactoring is about changing your implementation details. Okay. So the key thing we're trying to do is hide information. We hide design decisions that are likely to change. Data structures and schemas that we might use inside our module, where effectively even things like how we save it to basically the data store, right? Algorithms that we may want to use internally that tell us things like, in the case we'll look at later, who won this particular contest, right? External dependencies, things that I may depend on as a module which are external to the system that might change over time. All those things we don't want to expose to everybody else. If a decision is hard to change later, hide it behind a module. All right, John Osterhaus, in his philosophy of software design, talked about two different types of modules. So there are basically deep modules. They have a narrow interface. In other words, they don't expose many types from outside the module, and a deep implementation. So most of the detail is hidden in the implementation. You as the caller deal with a narrow interface, and you don't know most implementation details. Shallow modules have a wide interface that is pretty much close to being the implementation. We prefer deep modules because deep modules hide complexity from collaborators, be that code or be that people. Right. Pause while I drink some coffee. So you should strive to reduce the surface area. I'll show you later if we have enough time, run time to look at some of the code. I'll show you, I was reviewing it earlier this morning, and I could see, hey, maybe there's a detail here I can hide. And that's what you want to be doing the whole time. Look for the details you can hide. Again, we'll return to the same themes a few times. One of the things to watch for here is the temptation to expose stuff from your module so that you can write a test against it, right? Don't do that. Your tests basically should come in a test-driven style from you effectively working against the interface of the module. You create basically a public type, which will express the behavior of the module. You go away and you write an implementation, and then you look at that implementation, and then refactoring step, you say, much of this 400-line method that I've written to basically go green, because you commit sins to go green in TDD, needs to be broken up into a series of collaborating classes. Those will all be part of my implementation of my module, and I do not need to write separate tests for them. All right? So if you find yourself on the right, you will occasionally, but you need to review. Right? Sometimes you genuinely have a shallow module. We'll talk a little bit about some other rules later, but generally review at that point. Is that right? Could I make this deeper? So typically what we talk about is this notion of a facade. The notion of facade is when something effectively hides complexity behind it. So we think of a module as having a kind of facade at the edge, which represents what is the behavior that the module expresses and implementation details inside it, right? So here you got an example. The client is calling, well, again, we'll talk about what this all means, but basically a thing that frames the contest for you, which basically is an interface, which essentially is what we want to expose. And that says I can frame a contest, but inside there are various types that we use to do that, but there may be an implementation detail. It's actually not a great example, this one, because actually that one ends up exposing a lot of stuff. But all right. So in C#, how do we do modules? So in principle, we have lots of ways to do information hiding and break up our code within C#. So we have a method. Method is basically a form of module, right? Is essentially a name which is hiding implementation details and which you can treat as a black box, right? A class. So a class also really acts as a module because effectively you can have private state to a class or protected state, which effectively hides your implementation details, and it has a public set of methods or interface, which effectively is the behavior that you are exposing to the outside world. People quite often, I see in the kind of .NET space, tend to believe that they can use namespaces as modules. Namespaces are not modules. All namespaces do is they control the visibility of names, as it suggests. And you can, although in theory people believe that effectively it follows your folder structure, actually it doesn't need to, and it doesn't even need to be basically within your assembly. And hell, if you want, you can put things in the system namespace if you would like, right? So namespaces are a really poor mechanism for trying to achieve modularity. If one of the things you take away from this is namespaces and folder structures are poor routes to modularity, and they tend to be overly used in the .NET space. Don't use them for modularity. Assemblies, which tend to be underused, are a key mechanism for modularity because basically they hide things that are private or internal and they expose things that are public. So our preference generally when we talk about modules, because really in most cases we are looking for something a bit more than a class or a method, is to use an assembly. They basically provide information hiding, and they can effectively provide deep module structures. The problem with picking a class is that I have all the classes that I therefore have inside my application would effectively be exposed to each other, and I don't necessarily, unless I've got a very low complexity, I will probably end up coupling things that don't need to be coupled to each other, right? Because they're inside a single assembly, even if they were internal, they're all visible to each other. And we end up with what we call pathological or basically common coupling. So we want to avoid that. Okay, I always wondered whether I should put this slide in when I was doing it, but I want to talk to this because I see this as potentially being a problem. There are 3 access modifiers, basically, that are in C# that you care about for our purpose. There's protected as well, but we're not going to worry about that because it's much more to do with inheritance hierarchies. So public, my export is visible inside the module, in other words, an assembly. Internal are local. I'm an implementation detail of the module. In other words, I can be seen inside the assembly, but not within another assembly. And private, I'm the implementation details of a class. See, I still believe it's true. I believe that the default for basically, most things, when you write a class, is you don't put a modifier in it so it's internal, right? So why is the default to make something internal? And that is because that's what we want. We want the default to be that a new class we create is internal and only visible within the module. It should be a deliberate decision to make something public and to expose it and say, other people in other modules will need to call this, and I should think carefully about that contract. Back in the day when refactoring tools first came out, there was obviously JetBrains with ReSharper, but there was also DevExpress, and I forget the name of DevExpress's refactoring tool. But DevExpress's refactoring tool would not let you refactor something that was public. It basically said that is an unsafe change. And the reason is because how do I know who's calling that? My module exports it, I have no idea who's calling that. Now, what DevExpress later modified it to was to let you say, okay, I'm going to promise you that my assembly is only used within this solution, so I will let you refactor the public interface or change it because I can give you where effectively that change will be bounded to. It's the solution file. But I see a lot of .NET developers tending to basically just whack public onto any type that they create without thinking about the fact that I have now essentially got pathological coupling everywhere because I haven't taken control of how those items are visible. Generally, the default is correct, right? It should be internal unless you choose to make it public. And again, return to this idea. If you're doing test-first development, right, then generally speaking, start with the thing that is the exports on the module, get green, and then build out your implementation details, but make those details internal. Okay. Which leads to this like line in red, right? How many of you have got things where you have assemblies which are using internals visible to expose externals to tests? A few of you? Please stop doing that. So many of you have done it that every time I talk to an agent, it tries to do it. Because agents are just trained with all our bad behaviors. So you can tell what everyone's bad behaviors are because you have to put the agent on the naughty step because your agent has effectively done that. The reason you tend to do that, I completely understand, is because you think that I need to test this class, right? Therefore, effectively, I need to basically get it under test. I'm going to have to make it public. I don't want to make it public. I'll just make it internals visible to. The test can have privileged access. It is an implementation detail. Do not couple your tests to implementation details, right? I've got a couple of talks about this. Kent Beck's got a thing called the test desiderata. You can go and read, which says pretty much the same thing. Do not couple tests to details. Why? Because then you can't refactor, right? Refactoring allows you to change the implementation details as much as you want. The tests, which are against the public interface of the module, don't have to change because we're not changing the public interface during refactoring. But the implementation details of the module, of the assembly, can change as much as we wish. Okay. So typically, internal classes should not be driven by unit tests directly. They emerge as implementation details through your refactoring, right? So I write my public, and then I basically keep working through this process of trying to say, okay, I want to make that public class, whatever that I've exposed here, I want to improve it, so I'm going to keep refactoring bits out of it to essentially create its implementation details, but those would be internal. And I can change them as much as I want. The contract of my module is preserved. It doesn't matter to anybody else what I do, right? So that will help you reduce the number of tests you write. Because with any module, you're just doing basically TDD against the perimeter of the module, right? Against its facade, not against its details. Modules are not layers. Right, this is a common one. I know this is common because if you ask agents, they'll try and write this for you. All right. What you've done is you've confused two things. You've confused an organizing structure for your modules, which are the layers, and modules themselves. Right. So application, domain, and infrastructure is a classic layered architecture. And what a layered architecture actually says to you is, what are the constraints I want to put on how modules depend on each other? And in this layer, there will be those constraints. But they are not modules. As soon as you do this, you are basically saying, I don't understand assemblies, I don't understand modules, right? So stop doing that. It doesn't make any sense to do this, right? You're using a module mechanism to define a layer, right? Actually, it might be that when I look at your code, I cannot see the layers. That is fine. The layers are rules about how things depend on each other. That is what you potentially may want to enforce for something like depends, where essentially you say, okay, these things have this dependency rule with these things because I'm enforcing that layer. The other thing is layers. We're talking about organization a bit later, don't have to be these, right? You could have any set of layers you want. It's just about having rules for how modules in one layer can depend on another. Don't do this either, right? This is like really fashionable right now. It basically says, oh, what I'll do is I will use the file system as an organizing principle for my .NET project. And in that, I will have folders, and in my folders, I will put things like, oh, here's co-located everything I need to do to create an order. Here's everything I need to do to read an order or whatever, right? You just have common or pathological coupling here. You have no information hiding. You have no ability to use access modifiers to protect one part of your code from another. You understand probably what a module is, because these features could be an awful lot like modules, although they are trending a little bit towards basically an entity module, anti-pan. But you've not got a module here. Then even if you have namespacing organized around this folder structure, as I said, I could put everything in the my app namespace and it wouldn't care. I could put everything here in the system namespace and it wouldn't care, right? That is not a principle which is going to defend your code. I know some people then respond, but I have written architecture tests which enforce the module boundaries. Great. You have just coupled a whole load of tests to your implementation details, not to your observable behavior, and made your software rigid and brittle to change. Right? Some of you are going to give me a red ticket now. That is fine. I know that you're all sitting there going, I like my folder structure. Please, I went to talk about vertical slices and they said I should use the folder structure. Ian's getting a red ticket. I know, but don't do this. You're not benefiting from the language constructs designed to give you information hiding. The file system is not part of the language. It doesn't give you anything. Right? You want something that looks a lot more like this, all right? Underneath source, what you've got is a set of modules which hide key design decisions and ideas, all right? If we get time, we'll have a look at exactly what this looks like a bit more. But your assembly is a module, and it has a narrow interface, right? And it has depth, and its details are hidden from other modules. Your tests are at the edge, and effectively, your details can be rapidly refactored if you wish to. All right, so a bit of review. The assembly is the module boundary in C#. Public access modifiers indicate exports from your module. Internal is an implementation detail of your module, which can change. It should not have tests against it, right? It is a detail which you can refactor easily. Your export should be narrow, deep module, use some kind of facade that represents the overall thing that's happening inside. Your exports may be an interface, right? Because effectively, you may say, oh, I'm going to implement this interface, maybe others. Typically, you have to have some strategy, either like basically assembly with interfaces in it that you say, hey, man, you can implement this, or you have a layered strategy which says the layer above defines the interface that I then implement, right? But effectively, you may want to have multiple interfaces. Don't use internals visible to, right? Because you don't want to basically couple to your internals. Testing, right? Your test should test your public exports from your module. Your module effectively is a black box which you are unit testing, right? Integration tests then span between modules so they work together. Refactoring is changing the implementation details of your module. It is not changing the public exports. Makes sense? I think it's important that we kind of grasp that, because there's a few sacred cows in the .NET community we've just sort of slaughtered. Part of the reason I gave this talk is I have become continually frustrated with people in the .NET community showing examples of, look at my wonderful folder structure. This is the future of .NET, and I cry a little bit inside every time. And like I say, I can tell everyone's doing bad things because my agents do them instinctively, so I know that basically that's the corpus of work that it's been trained on. All right. We talked about it a little bit earlier, but let's try and have a little bit of an example so I can talk to it a bit more easily. Besides building and talking about software, I also play and write some role-playing game stuff. So I wrote a new edition of this game. It doesn't really matter what it is. You could be excited and get a copy if you like on drive-thru or at Chaosium Store. But so what I want to talk about is this idea. So some of you have seen I do a talk about responsibility-driven design. Responsibility-driven design, for those of you who don't know, is the thing that underlies domain-driven design that you've never heard of. You go and do domain-driven design and say, oh, I do domain-driven design. And I say to you, do you know about responsibility-driven design? You go, no. And I go, how are you doing domain-driven design? Because domain-driven design says it is basically responsibility-driven design, plus a lot of other stuff, right? So in responsibility-driven design, one of the things we do is create what we call a design story. It's basically not the requirements. It's a way of us thinking about how we divide up roles, responsibilities, etc. within our software. Responsibility-driven design tends to think about object neighborhoods. They're pretty similar to modules, but this technique is also pretty useful for figuring out what responsibilities you might want to give to a module. So roughly, the GM wants to run quest worlds, contest with a player, open a quest worlds website. This is what we want to build, generate a session ID, which they share with their players. GM creates a new contest, entering the prize and setting the target number for the resistance. Player joins the session, records the ability they believe will help them overcome the obstacle in its rating. The GM determines any stretch, situational modifiers, hindrances, and arguments, and then the system then rolls a D20, 20-sided dice of both the GM, I should say, and the player. System evaluates the results, adjudicates the winner, and determines the possible consequences or benefits. The outcome is shared with the GM and the player. So the short version of this is, if you play role-playing games online, as a lot of us did in the pandemic and have done since, it's useful to have a mechanism to actually try and resolve contests other than just using a dice roller in Discord or whatever. I'm not expecting you to read this. There is a flowchart which represents how this all works. That's effectively what we need to get under code, right? Okay. So why tell you that now at this point? So one of our key things then is we're going to need to find our modules, right? Because breaking up something into modules, as we said, is the kind of key activity, right? So software has always been about breaking things down into smaller solvable problems. Okay. So there are different ways we can do this. None of them are necessarily better or worse. They all have their advocates. Those advocates will tell you that their way is best and the other way is not. But so one way is effectively what we think of as workflow decomposition. So it says, probably I want to think about modules, finding modules by looking at steps in the workflow. So that's everything as modern as event storming and as old as BPMN, right? And you can do it without either of those techniques. You're just literally saying to yourself, I wonder, what would be the next big thing that we would do to accomplish this? So it's something like we've just been talking about with Quest Worlds contests. Well, that description seems quite workflow-like, right? There is a process we are following that has a number of steps that leads to an outcome. Maybe workflow decomposition would be good. The other set of models tend to be what we call act-to-action models, right? So again, use cases for those of you like me who are a little bit older. Domain storytelling, which is a very modern and cool thing that kind of inherits some use cases and idea. Responsibility-driven design, which is about effectively assigning responsibilities, grouping them into roles, etc., is also a valuable technique for thinking about module boundaries. So there are different ways of doing it, right? And so we're going to be quite high level about it rather than picking a specific methodology, but feel free to use a methodology yourselves when you're doing it. We just haven't got time to cover all the methodologies. Okay. So the basic form of workflow decomposition looks like this, right? In other words, I can break my thing I'm doing into a series of steps. Each step is potentially a module. So think about this when effectively what you're doing has a strong process feel to it, right? Basically you think, oh, well, this thing that I'm trying to build is actually a process. I can think about it in terms of the tasks that need to be carried out in the process. I can think about those tasks being modules. If you're actually doing orchestration with some kind of workflow engine, typically you'll find in the workflow engine the tasks are not the modules. The tasks call your module, but it's a difference of semantics over worrying about how you think about using this technique to decompose into modules. So with Quest Worlds, for example, given the kind of description that we had, We know that we want this idea of a GM creates a session where he's going to play the game with his players. The GM frames the contest, so says, what is this about? What is at stake? What is the resistance that you are facing to the actions that you are doing? The player then picks their ability and enters their numbers. We then press the button, right? Run the contest. That's the resolution system. It basically rolls a couple of D20 for us, figures out what that means, and says, you know, you died horribly or whatever, basically, in the resolution. And then the outcome is really about presenting that back. How do we effectively turn that and its consequences? For example, there are some mechanical consequences to the resolution in the game, which we may present back to you. So from a workflow model, those would look like useful candidate modules, right? And because we're doing often solution design rather than system design, I would say sometimes before you reach the big heavyweight processes like event storming, you can just do something like this, right? It'll give you a good enough first attempt that you can probably then evolve as you code. Actors and actions. Ooh, poor choice of colors there, Ian. An actor performs an action on a target. So you can divide use cases, domain storytelling, pretty much into this concept that you have the idea of an actor, which might be a system or a person. They want to do something, and they tend to want to do something on some kind of work item, typically, right? And this is usually a good way of thinking about your modular division. If you've got something that's very, excuse me, user-centric. So, some cases you get kind of both, but it's easier to show you a bit of a diagram here. So here you can see what's happening is the GM is creating a contest, framing the prize for the contest, setting the resistance. The player is determining their ability and adding their modifier, right? So we can think about basically what we're doing in terms of actors and actions. And then when we have the actors and actions, we can think about clustering those actions within modules. So we can say, well, look, the GM creating a contest and determining ability belongs in this framing module, right? Now I'm just using the same modular breakdown I did in workflow, but you might, when you do this, end up with a slightly different one, right? So you assign the responsibility for these particular actions to given modules. This is very similar to what you do in responsibility-driven design to find classes. And in a sense, you're doing the same thing, right? But what you're likely to find is that the RDD works a little bit more to find you the things inside the module. What you care about at this level is just bucketing stuff into given modules where you can figure out the actual design of those internals later. When we have a set of modules, we want to review them. When we review them, what we want to do is think about how do I know this is a useful set of modules, this is a good breakdown that I've got from that particular journey, right? So the first thing is we can think about David Parnas. So David Parnas wrote a famous article basically on the criteria to be used for the decomposition of software into modules. Written in the 1970s, remains a bit of a touchstone for many people. His key insight basically is that you want to make sure that for maintainability, that beyond just simply encoding the workflow, the steps in the workflow are essentially hiding key design decisions that need to change. So when he looked at classic there are some what are called candidate problems in software architecture, which you may never have heard of. But when he looked at analysis of a solution to some of those problems, they would find that things that hid information about key design decisions in that flow, such as how to run a contest, were more maintainable than things that didn't. Coupling, how connected are you to other modules? So afferent coupling and efferent coupling. So afferent coupling is basically who depends on me, and efferent coupling is who do I depend on. I always get the two confused. people have different mnemonics for remembering afferent versus efferent, but the key point you're worried about is whether you're saying, I care about who depends on me and I care about who I depend on, and if there are too many of those, I've got a problem, right? And the entity trap. So there's a danger of writing basically modules that are just aggregates or entity wrappers. So a little bit more on that. Parnas test is, what decision does this module hide? That's a quote from Parnas. Begin with a list of difficult design decisions or design decisions likely to change. Each module hides a decision from each other. So when I think about quest worlds, right, there are design decisions around how we do contest resolution. That's a key algorithm. It should be hidden from something that wants to basically just create a session for us, right? The thing that creates a session doesn't need to know how we resolve a contest. That is an implementation detail. Many of the details of how we resolve a contest should be hidden. Outside, really, I just want to say, resolve the contest. The implementation should understand what that means in terms of the mechanics of the game. Because, you know, we might release another version and change the mechanics slightly. We wouldn't want to have to alter the whole game system too much. Coupling, so afferent, who depends on me, efferent, who do I depend on? High afferent, it means I've got many dependents, so it is harder for me to change because essentially I may impact many people, and that can go beyond the notion of just you are coupled to the signatures of my methods to actually there is implicit understanding of how I work that you may basically depend on, and if I change that, they may alter you even if I haven't changed the interface. And who do I depend on, right? Who might force me to change? This talk is not going to go into the depths of coupling, connaissance, everything else. There are plenty of good talks about that, and we've only got an hour, not several days together. All right. But our goal is to try and minimize coupling and maintain cohesion. You can essentially do a broad look basically at your coupling by simply counting the number of things that depend on you and counting the number of things you depend on. And if that number is high, saying we should review the value of this module, right? So here you can see A, B, C, and D. The question about B would become, hey, everything routes its way through B to get to C and D. Is B just going to cause us a problem that every time we want to make a change, it has to kind of ripple all the way down? Is there actual value, or should A just talk to C and D? All right. So that's the kind of review that you want to use when you're thinking about modules. Entity trap, right? There can be a tendency to create modules around an aggregate or an entity, right? And just basically have the module expose CRUD mechanics on that entity. That's really a bad choice, okay, because effectively you're hiding the structure, not the decisions. Modules typically, good modules expose behavior. They don't expose data structure. There is a note on this. It is hard to do this completely. Some things are just, this thing holds data. So don't beat yourself up if you find, oh, I've got some of these and I can't get rid of them easily, right? So in the case of the example code, the framing is just really you enter lots of data about what the contest is. What's the state, what's the resistant, what modifiers apply, what ability were you using, which is effectively what then feeds in to the resolution. It's really hard to get away from that. You've got to capture the data at some point. You're probably going to have a thing that represents that data structure. I could say it's part of resolution, but really there are some rules about framing, about how and interpreting basically information that we're being given, like codes of values and stuff. So it's there is some implementation hiding going on, but really it pretty much ends up as an aggregate. So avoid it, but recognize that you're going to get some of them, right? So we end up with session, which hides this session lifecycle. That's basically you setting up a game session and then giving a code to your players who can all then log in. Framing hides the implementation of contest setup, right? The risk here is that's actually just an aggregate. Resolution hides dice roll and success calculation. It basically understands the game mechanics and can effectively resolve the game, outcome, what is the results, because of that resolution, what is the game impact, what happens? Okay. Organizing modules. So we can organize modules in a number of ways. And it's important to talk about this because I want to distinguish between modules and the organizational techniques, right? So typically there are three I would bucket: technical, flow, and domain. Technical, we organize modules by the technical role. Flow, we organize by the flow of the data. And domain, we organize by the domain role. So typical technical architectures are layers, classic layered architecture. What layered architecture just says is there are rules about what a module in a given layer can depend on. Typically, you can only depend downwards, right? So I can effectively only depend on things that are below me, right? Ports and adapters, which we'll flick over to just so we can see an example of one, has a different set of rules, but generally they're just rules about module dependency, right? So, ports and adapters, this model here basically says, hey, all my domain logic lives in the middle in what hexagonal architecture confusingly calls basically the application. And essentially, there are driving on the left-hand side, driving ports and driven ports on the right-hand side. So driving ports, things that go in and make my application do stuff. Driven ports, things that basically my application needs to talk to outside the application. So typically I/O, databases, queue are effectively driven, and we call those driven adapters, the things that plug into those ports. And driving adapters, HTTP and CLI, plug into the driving port. So a port you can think of like a socket, and the adapters like plugs, they plug into the socket. There are significant advantages to this architecture. For example, you can drive the application through tests. All right. When we think about this kind of architecture, the application would contain one or more modules. It may be a single module. I've got a very shallow application. There's not much there, right? But it may be many modules because we're splitting up basically a whole set of different responsibilities that our application has within our domain. Your adapters, the things in the blue boxes, are typically modules. And the ports are just effectively your facade into the application or from the application out to the things it needs to basically send messages and stuff to. All right. Flow-based architectures, so things like pipes and filters or flow-based programming, where effectively data flows through transforming behaviors. So in essence, the modules, are behavioral transformations. So pipes and filters is a classic one you probably all know. You have a data source, you have a data sink, and you have a series of filters, sometimes called operations, right? Things like Flink, a poster children for this. And essentially your data moves through, often by stream processing, to essentially be transformed in every filter along the way. The modules are effectively your operational steps, your filters. They perform some kind of single transformation. They are independent of each other, they are composable, and they don't know anything about the neighbors, right? I just know that I get data in, I perform my transformation, and data comes out of me. So that's really good for data processing, ETL, event streams. Domain-based architectures. They're a little bit weird. But people like vertical slice and CQRS we quite often typify as domain-based architectures. In a sense, the modules are organized our domain, and the architecture is organized around domain use cases. So vertical slices. Vertical slices are a bit of a problem, people. And they are a problem because all of you are building them with folder structures and the like, and you are not taking advantage of modularity. You've just got some kind of like, hey, I want to use the file system as an organizing principle. But in a good world of vertical slices, what are vertical slices is a layered architecture in which you have effectively created slices through that layered architecture, right? And so essentially, what you're saying is the same thing as a layered architecture. You have rules about what can depend on what, and effectively inside your slice, and your slice itself represents a narrow portion of functionality. In principle, then each slice would contain multiple modules. I don't think vertical slice architecture is great. I think it is confusing several ideas together, particularly in its use of folder structures, right? Again, you're probably giving red tickets for that, but I don't care. The reality is that basically your problem here is typically that people don't do what vertical slice promises, which is says, hey, in create contest, I could be a transaction script. In join session, I'm going to be a domain model, and basically choose appropriate tactics like, oh, join session needs to have modules inside it. They just put everything in the folder structure, right? So vertical slice could be good, could be great, because it would give you, oh, I've got different actual architectural responses at this point, but if you just put it all in a folder structure, you have effectively done nothing to control your coupling, and nothing to improve your cohesion, and nothing to hide your implementation details. And you'll probably find if you try and put modules in vertical slices, it becomes quite confusing to you. CQRS. So CQRS basically really just says, I've got two clusters of modules. I have modules that basically deal with queries, and I have modules that deal with commands, right? And essentially, those modules deal with different models of the world, and it's a perfectly valid way of effectively building your interface to your modules. So what you think about is that the command handlers and the query handlers effectively become the interfaces to the modules that hide the implementation details of how stuff gets done. So you're just, rather than having a method call interface to your module effectively has a handler which essentially is the entry point in, and effectively your command or query routes to that given instance of a module. And if you're sophisticated, so for example, Bright has a thing called an agreement dispatcher, which means you can do routing to different alternatives based on, for example, date, then essentially you would effectively be able to say, okay, use this module for tax calculations to this point and this module for tax calculations for that point, and have two different modules of tax calculations side by side. That's the kind of the wins you can get out of that CQRS module approach. But again, none of these things are actually modules. They are organizing principles for your modules. That makes sense? Because I feel like this point gets really confused. Lots of architectures are really hybrids, right? In other words, they don't really obey one of these. They obey many of them. So you can build a pipes and filters architecture and say, hey, my filter is a ports and adapters architecture. It's basically got an adapter, and it does I/O with that, effectively, etc. And it's basically got driven ports, and it talks to a database, and I've got an application in the center. That's perfectly fine. You can effectively nest these architectural styles, right? Architectural styles do nest. You might have a vertical slice architecture where an individual slice is actually CQRS, because effectively it's dealing with a command handler and then kicking off a whole load of results below it, right? Which may be a transactional script in this case, and over here it may actually be a modular domain. So CQRS architecture itself might effectively be tricking off a ports and adapters architecture. So these things are not independent of each other, right? You can build hybrid architectural styles. It's turtles all the way down, right? This goes back to Mary Shaw and effectively talking about architectural styles and box and lines diagrams, where they come from back in late 80s, early 90s. And always these boxes are seen as being turtles all the way down, right? You can put another one inside another one. The key thing is basically your architectural style is not expressed by modules. Your modules are organized by an architectural style, right? So your assemblies are not your architecture. They are your modules, but the organization of your assemblies, right, is effectively the architectural style. And don't rely on folders for your architectural style. Quest worlds, basically, we just choose ports and adapters, domain logic in the center, divided into multiple modules, adapters, storage, and UI, right? Okay, some other quick ones. We got time, yeah, okay. I'll show you the code right at the very end, but you can go and look at the repo if you need to, right? So narrow interfaces help you in a number of scenarios. Testing, we've kind of talked about a little bit. We'll get into it again. Feature flags, deployment, AI assistance, right? So you take nothing else away, right? The big win of modules is that effectively that is the testing boundary. You do test first against the module interface. You test the behavior, not the implementation details. It tends to liberate you from excessive mocking. It reduces the number of tests you have to write, and yet your software is still as protected as it always was, because you don't couple the implementation details of your module to the test, right? So that module is a unit, right? For those of you, who's writing code with agents these days? Right, quite a few of you. Yeah. Modules are great for agents because I can tell the agent work in this module. That means effectively I can prevent a couple of things. If I get really good and start running Git work tree and basically want to have multiple agents working in parallel, if they're working on different modules, then I don't really have so much of a problem with merge, right? It's basically a nice clean interface. It's very easy to say to the module, effectively, this is what we must agree in part of my design document. Here is the public interface. Everything else we'll understand and work with. We get to work against the implementation details. It's generational isolation, verifiable, because effectively you just say, hey, agent, I need you to write tests basically first. Agents work better if you write tests first, so that I can prove the work you've done, and that should be against the boundary of the module. All right. So it helps significantly to work with agents this way. Feature flags, right? Modules are great places for optionality. You can either have simple decision, this module is currently on or off, right? Things that go into it just bounce off where this module is not activated yet, or it's the point at the surface of the module where effectively you can turn behaviors on and off to allow you more fine-grained control with feature flags if you need it, right? But it really helps you to be able to understand this. I've seen people work with code bases that have no modularity and they need to feature flag something and it's a nightmare because effectively they have to push it all the way through, right? Deployment, right? Modules allow us to basically say, I'm going to ship a version of this software configured with this version of the module. I can have a canary deployment, which everything else is running with the old version. This one's running with the new version. I can try and experiment with much more easily. Let's try a new implementation of this module that maybe I think is going to be more performant, and we'll basically launch that to 2% of our customers and see whether or not that actually works. And if not, we can easily roll it back. Modules that you change bits and you understand what it is that I've changed. Or even feature flag it out, right? Hey, we're adding a new module for a new feature. Oh, that doesn't actually work as well as we want. Rather than roll back, we can just turn it off, right? And then effectively people just lose that bit of functionality. Modular monoliths and microservices. Gosh, I mean, you'll probably give me a red ticket for this as well. But I hate the term modular monolith, right? With a passion, right? Modularity, a modular monolith is not really a thing, right? So modular code applies to microservices, to monoliths, to anything you write, right? You are effectively being modular. Modular monolith is a strange term. It implies basically you can't have modules elsewhere, right? The whole point of code, again at the beginning, the fundamental law of software is essentially break things into pieces with individual responsibility, and modules are the way you do that, right? So modules aren't about maintainability. Modules are not domains, and domains are not modules. They are different concepts. If you look at the quote at the bottom from Eric, the modules in the domain layer should emerge as a meaningful part of the model, telling the story of the domain on a larger scale. They are a different mechanism, just like aggregates or entities, etc., which you use as part of doing DDD to help you understand the domain. If you're doing DDD, you give your modules meaningful names in the ubiquitous language. You try and relate them to domain concepts that seem basically to be structured. But just because you divide your code up into modules does not mean you have got something where you go, yeah, see, all my modules, they're bounded contexts, and I will easily be able to turn this into microservices at the push of a button where each one of these modules becomes a separate microservice. That is not how you do it, folks, right? Your modules are a way of hiding design decisions, and you may have many design decisions in your domain that need to get hidden from other parts of the domain, right? So they're not the same thing. Domains may encompass multiple modules. So I'm not against the idea of you building a monolith as opposed to a microservice. That's a perfectly good design decision. And I'm not against the idea of you breaking up software into modules. I just don't equate the idea of a module and a bounded context. They are not related concepts. All right. Wrap up. Take a requirement, break it up into modules by workflow or act action, review your modules for coupling, entity trap, choose some kind of organizational strategy and architectural style, right? and then you can work with the modules using TDD and stuff. What I'll just show you briefly, I've just got a few seconds left. So this is some code I wrote. You can go and find it on my GitHub, which is just, if you just do GitHub Ian Cooper, you'll find me. So this implements that game. You can go and read through it for yourselves. The only thing that's probably interesting to show you here, right, is we have a number of modules that are just assemblies, right? In one or two cases, you'll find that we have, let's do one over here. Let's do this one. So you'd find here that the contest resolver is, if you like, the public class. Oh, that's the internal class. Where is the contest resolver? Yeah, and it calls some internal classes like adjudicator, right, etc., to get the work done, the implementation details of what we're doing. That's probably a bit small. Let me just. That's not making it bigger. I don't know why. There you go. All right. And that is what you're looking for, this kind of model where my external kind of method to the module is essentially delegating the work to internal classes inside the module. And the structure of that is much easier for someone to understand, but I could refactor this. All I need to preserve as my signature is resolve the contest with these dice rolls. And this will go and figure out how that all works, right? So that's the kind of model you're looking for when you go through this. You will also find, I think I've got one open, it's a process sometimes. Where is my, oh yeah, contest hub. Here, right, for example, I'm calling a contest frame. So basically we have a notation in the game which is like 5M, which means 25, and M just means you get an extra success and you roll against a 5. So it needs to parse that information when you hand it in. Now, actually, I've got here this thing which basically says contest frame, target number from rating, and rating parse. Probably, it's a smell here that rating is probably an implementation detail. Probably I could just pass the resistance target number into the contest frame and do the parsing inside, because I might choose to change my parsing algorithm, for example. Anyway, go and have a look. That hopefully will give you an idea. And you can also see there is no architectural style baked in here. All right. Thank you very much, everybody. If you're coming, green tickets would be lovely. Some of you may be fans of vertical slices and folders and want to give me red tickets. I feel you. But thanks very much.